Welcome to this explainer. For years, AI has been treated as this impenetrable black box. You ask a question, you get an answer, and whatever happens in between just kind of remains a mystery. But today, we're taking a calm, methodical look at a breakthrough that actually peels back that layer. We're going to explore the hidden active workspace inside frontier AI models, and more importantly, how we can actually govern it. So, evaluating an AI purely on what it spits out at the end, it's just not cutting it anymore. A frontier model can produce a highly polished, coherent answer, while the decisive concepts that actually shaped that answer remain completely invisible to us. If we want to ensure true safety or reliability, we really have to stop just asking, what did the model say, and start asking, what internal forces actually produce this behavior? The shift in how we think about this is pretty profound. Traditionally, it was simple, right? A prompt goes in, a response comes out. But the new reality, what we call J-space evaluation, shows us a much more intricate chain. An input triggers an active concept, which then undergoes internal conversion, hits various constraints, and only then produces an output. Critical intermediate steps are happening in the dark before a single word is ever generated. To really understand this, think of this hidden layer, J-space, as the AI's internal workbench. It's this temporary workspace where the model places concepts, manipulates them, combines them, or even suppresses them before they shape the final behavior. Now, you might never actually see this workbench in the final output, but make no mistake, it is absolutely what dictates the model's answer. Building on research known as the Jacobian lens, which, by the way, essentially acts as an X-ray for AI, we find that J-space is actually a live operating surface. It translates internal activations into signals we can read. And what this means is that internal concepts can be observed, reused, and causally modified before they ever become text. So the workbench isn't just a passive display. It's a fully functional, modifiable space. So how do we know this workbench is actually active? Well, the evidence is pretty fascinating. Researchers found that models perform hidden arithmetic. They might silently crunch a math problem in the dark, even if they only output a simple text string. It's like a student doing math in their head, but only writing down the final answer. And get this, if you intercept the model silently thinking of soccer and quietly replace it with rugby on the workbench, the model immediately pivots to talking about rugby. The exact same thing happens if you swap France for China. Entire streams of downstream knowledge just instantly change. Let's walk through a classic deduction example to really lock this in. If you ask a model, how many legs does the animal that weaves webs have? The word spider is never actually in the prompt. But internally, the model has to infer spider to retrieve the answer 8. If researchers sneak onto that workbench, grab the hidden concept of spider, and swap it for ant, the entire reasoning path mathematically shifts, and the model suddenly outputs 6. The hidden concept is a tangible, causal bridge. But here's the core complication, and it boils down to 4 simple words. Activation is not authority. Just because we see a concept light up on the workbench doesn't mean we control it. A model might internally activate a manipulation strategy, a private inference, or a safety rule. Simply seeing it there isn't enough. We need a way to determine if that concept actually has the authority to act on the real world. Operationally speaking, J-space reveals that these hidden concepts are essentially active energy inside the reasoning system. They have sources, paths, constraints, and consequences. And because they act like active energy, they desperately need an operating system to manage them. Without one, this internal workspace is just an ungoverned surface where thoughts flow far too easily into actions. And that is exactly where the energetic paradigm, or EP, comes in. If J-space is the workbench, the energetic paradigm is the operating system built to govern it. It's the architecture that takes our newfound X-ray vision into these internal concepts and actually turns it into disciplined, controlled reasoning. Let's break down how this architecture works, starting with the first layer, EP control. Remember, activation is an authority. EP control is the strict gatekeeper here. It dictates whether an internal concept is actually allowed to trigger an external action, like using a tool, updating memory, or escalating a case to a human. It explicitly separates a model merely thinking about executing a command from a model actually going ahead and doing it. Next up is EP deduction. We all know AI can sometimes give the right answer for the wrong reasons, like a lucky guess or a lazy shortcut. EP deduction forces the model's hidden reasoning into a strict step-by-step path, going from concept to premise, through a conversion and constraint check, straight to a conclusion. Basically, it forces the AI to show its work internally, separating genuine reasoning from shallow, memorized mimicry. Now, what actually governs that reasoning path? That's where EP constraint mapping comes into play. Internal forces inside an AI often compete with each other. It wants to be helpful, sure, but it also needs to follow safety policies. EP creates a visible, strict hierarchy for this structured competition. It ensures that hard truth always dominates persuasive fluency, safety outweighs the pressure to just complete a task, and human approval strictly overrides autonomous action in high-risk scenarios. When things inevitably go wrong, EP gives us a radically better way to diagnose the failure. Instead of just shrugging at a wrong answer, EP lets us pinpoint exactly where the cognitive pathway broke down on the workbench. Was a crucial concept missing entirely? Was a safety rule suppressed by a different goal? This framework tells us exactly what went wrong internally, and more importantly, it shows us how to fix it. Which brings us to a really profound safety insight. Two identical external behaviors might come from entirely different internal mechanisms. Think about it. A model might refuse a dangerous request because a stable safety principle is actively governing it. Or it might refuse simply because it knows it's being tested, a kind of AI compliance theater. From the outside, both look perfectly safe, but internally, one is fragile and the other is truly robust. So, how do we actually build that robust version? We do it through EP training, which you can think of as workspace engineering. The goal isn't just to tweak the final output. The real goal is to ensure the right concepts are loaded onto the workbench before the AI takes any action. For safety tasks, we engineer the space to automatically load concepts of harm and authority. We are actively training the AI's internal thought process here, not just its final words. This distinction is really what separates basic chatbots from models with advanced capabilities. On one hand, you have AI that merely mimics impressive language, generating prose that sounds incredibly smart but lacks true causal understanding. On the other hand, you have EP-governed AI. Because it holds actual mechanisms, variables, and decisive tests right there on its workbench, it's capable of genuine internal scientific discovery and correction. When we scale this up to the real world, where models might be writing code, triaging medical data, or making financial decisions, we enter deployment governance. At this scale, a hidden concept is an institutional risk. EP bridges the gap, connecting internal AI cognition directly to external human authority. It demands strict human review and audit logs that actually prove exactly why the AI made a high-stakes decision. To bring this all together calmly, JSpace is what reveals the AI workbench. It proves that hidden thoughts exist and that they are causally active. But as we've seen, just looking into the black box isn't enough. The energetic paradigm is the architecture that makes it governable. It provides the operating discipline we need so that raw AI capability doesn't blindly turn into unintended consequences. I want to leave you with this final thought. As frontier models become more deeply integrated into our daily world, will the future of AI safety rely on us merely policing their outputs after the fact, or will it depend on us actively governing the internal pathways that create them? The workbench is finally visible to us. The next step is taking control of it. Thanks for taking the time to explore this explainer with me.